Hello students, welcome to the class. Now today we are going to start a new chapter, second chapter, that is matter around us pure? Okay, when we are saying pure means what? Anything which is consisting of one type only. Let us take some examples of a day-to-day life. Okay, you are going to the market buying something. Okay, suppose you have bought rice. That rice is consisting of other things also, some bits of pulses also, some bits of wheat also, some bits of pebbles also. Then will you say that that is pure? You will not say it. You will say no, it is not pure rice, it is consisting of other things also, so it is impure in nature. Okay, now if we are saying sugar, and you are buying only sugar and coming home, it doesn't consist of anything else, then you'll say that yes, it is pure, isn't it? Like all the things, they are having some definite constituents, and if they are consisting of only that constituent, it means that is a pure thing, isn't it? So here we are going to study what is first in chemistry a pure substance. A pure substance, what it is? It is a material which contains only one kind of particles, that are the atoms it can be, or it can be what? Molecules. If it is consisting of different atoms or different molecules, then it is not a pure substance. It must only consist of one type of thing only, not other types. If it is consisting other atoms or other molecules, it means that is not pure in nature. Okay, so here pure substances, they are basically homogeneous in nature and has got definite set of properties. Why we are saying, if we are talking about magnesium, it will consist of same type of particles, okay, same types of atoms as particles, okay. But if we are talking about salt consists of what? The formula of the salt is what? NaCl, isn't it? So it must consist of NaCl only, and this NaCl, sodium chloride, will have specific melting point and boiling point. So that is also a pure substance. So pure substances are divided into two: element and compound. If we are talking about elements, suppose the element magnesium, Mg is the for symbol of magnesium. It consists of how many electrons? 12 electrons, isn't it? So if I am adding one more to it, it becomes 13. Does this element will exist now, magnesium? No. It is what? Aluminium. Aluminium consists of 13 electrons. So here it means this elements consists of same types of atoms. Atoms like magnesium, it consists of only 12 electrons. Okay, you know all that atom is formed by electron, protons and neutrons. When I am talking about compound, suppose if H2, it is hydrogen in its molecular form and oxygen in its molecular form, when we pass electric arc, what happens in this? It forms what? H2O. When we are talking about this H2O, you are seeing these which were in the molecular form, hydrogen and oxygen, now they have formed in a fixed ratio, that is H2O. How do we say it is in a fixed ratio? Okay, so here the mass of hydrogen is 1, okay, and oxygen is what? How much? It is 16. It becomes what? 2:16, and you just simplify it, it becomes 1:8. Whenever this will be present, it will be present in the ratio 1:8. And now you can see here the water will have the same melting point, boiling point, density, everywhere same it will not be different. So I am saying, and this H2O is a pure substance because it is combined in the same in a fixed ratio. So here you can see, we can explain here now properly that yes, pure substances are homogeneous. When H2 and O2 mixes together, we can't separate H2 and we can't separate oxygen, and it has got the definite set of properties like melting point, boiling point, density. Very easy, we can say that water has got the boiling point of how much? 100 degree Celsius. Okay, now, so first, the pure substance, element and compound. So first we are going to study what? The element. So element is the term which was given by Lavoisier. Okay, it is a pure substance and consists of only one type of atom. Like copper, if I am saying this whole copper is the element copper, but the atom which it is consisting of, it is copper only. Like that of also aluminium, you can see aluminium symbol is what? Al. All will be aluminium. You can't see any other atoms in this element. Okay, it will consist of only of aluminium, and so it is a pure substance. So how many elements are discovered till now? Actually till now 118 elements have been discovered, out of which 92 are natural elements and 26 are artificial or man-made elements. These are prepared artificially by human beings. Okay, now so on the basis of properties, elements are classified into metals, non-metals and metalloids. So first we will be studying about metals. So metals, if we are saying 70% of the total elements are metals. Okay, out of which if we are seeing on earth crust, how much which is more in existence, that is aluminium, that consists of 8.3%, and iron, that is followed by iron, that is 5.1%. so most abundant element on the in the earth crust is aluminium, that is 8.3%, okay, of the whole metals. Now here if we are talking about the properties, metals, if we are saying they are solids at room temperature, but exception is that of what? Mercury. It exists in the form of what? Liquid form. Okay. Now if we talk about gallium and cesium, these two are also in the metal, are classified in metals only, and they also at room temperature they are solid, but they are liquid at 303 Kelvin. Okay. Now metals are malleable. So students, what do you mean by malleable? You have seen this aluminium wrappers by which you wrap your food. Okay, the silver which is been which is used for decorating the sweets. You can see this. See, malleable means when it is being hammered, it forms a big sheets. Okay, and as a result, it can be drawn into big sheets. Okay, metals are ductile. Ductiles means what? Ductile means it can be drawn into wires, like you can say about gold, aluminium, copper. You can see they can be made to form what? Wires. Okay, they are good conductors of heat and electricity. These metals are good conductors of electricity and heat, but here also exception is there of mercury, which is not a good conductor of what? Heat and electricity. Now lustrous. Metals are lustrous in nature. What do you mean by lustrous? Lustrous means shiny in nature. So whenever you see a metal, you will see that they are shiny in nature. Okay. Now next is they are generally hard. They are in the form of solid mainly, so they are hard in nature. But here exception comes of sodium and potassium. They are not hard in nature. They are soft and they can be cut with the help of a knife. Okay, they have got tensile strength. Tensile strength means too much power. Okay, like we are seeing the railway tracks, they are made up of iron, whole train runs over it, isn't it? The buildings, in the buildings also you will see that iron rods are used, and here also this whole building stands on that only, so it has got high tensile strength. Okay, it has got also high melting point and boiling point. Why it has got high melting and boiling point? It exists in the form of a solid state. Naturally the melting point and boiling point will be high. Okay, but here exception is of sodium and potassium. You can see over here sodium has got what? This 371 Kelvin, and potassium has got a 336 Kelvin, which is quite low temperature. Okay, now next you can see that they have got high density, but exception again is here of sodium and potassium. Everywhere you can see it is of sodium and potassium, so it is easy to remember. Okay, now metals are sonorous. What do you mean by sonorous? It means when it is it produces sound, tinkling sound, in which like the school bell you can see, when it is just the bell is rang, you can hear it, isn't it? That bell is made up of what? Iron, and that has got a specific sound which says that yes, the bell has rung, isn't it? So all the metals, if you see, even this is also made up of iron. You can see here also it produces a tingling sound. So metals are sonorous in nature. Now coming to the properties of non-metals, they may be solid, liquid, or in the gaseous form at room temperature. Okay, but if we are seeing of the examples like boron, carbon, sulfur and phosphorus, they exist in solid form. They are what? Non-metals. Bromine, which exists in the liquid form in the room temperature, while hydrogen, oxygen, nitrogen, chlorine, they all exist in the form of gaseous form. So in metals we have seen in board that they are mainly solid in nature. Exception was there of mercury, which was liquid at room temperature, but in non-metals all the forms, all the states of matter are present, that is the solid, liquid and in the gaseous form. Now these non-metals, they have got different colors. They are colorful in nature, as if you will see sulfur, okay, it is yellow in color. Okay, if you see phosphorus, it is red and or white in color. If you see chlorine, it is yellowish green in color. So these non-metals have got different colors. Now they are not malleable nor they are ductile. They can't be drawn into sheets by hammering, neither can it be formed in the form of wires. Okay, they are bad conductors of heat and electricity. In metals we have seen that they have good conductors of heat and electricity, where exception was that of mercury. But here this in non-metals, they are bad conductors of heat and electricity. They don't allow the electricity and heat to pass through. But here also there is an exception of what? Graphite. Graphite is an allotropic form of carbon. Now next point, you can see that these non-metals, they are dull in nature. They are not lustrous in nature, not shiny in nature. But the exception is of what? This exception is of what? Exception is of what? Iodine crystals. Okay, these iodine crystals, they are shining in nature and they are violet in color. Okay, now this non-metals, they are generally soft in nature. Okay, but you all know diamond is one of the hardest substance. So here exception, diamond is a non-metal, it is an allotropic form of carbon, so it is an exception over here. Now they have got low melting and boiling points. Okay, naturally as they are not malleable and ductile, they are brittle in nature. Naturally they will be having low melting and boiling point. But here there is an exception of boron, graphite and diamond. Density, we are saying density, they have got low density. Exception is of iodine, that also we can't say, but yes, relatively we can say it is high. Okay, and they are not sonorous. It means they don't produce the ringing sound when they are beaten or when they are hit. So they are not sonorous in nature. These are the properties of non-metals. Properties of metals we have studied. But yes, the third form is what? In which the elements exist is the metalloids. So these metalloids, when we are talking about these metalloids, they have the properties of both, intermediate of between what? The metals and the non-metals. It means it shows metal properties also, non-metal properties also. So it has got the intermediate properties. Okay, and some of the examples of a metalloids are what? Silicon, germanium, arsenic, bismuth and antimony. Okay students, so this is, today we have studied about what? The properties of metal, non-metal and metalloids, and this is all for today. Take care.